All right, everyone can hear me? Great. Well, thank you for having me. I'm Kalyan Veeramachaneni. I'm a principal research scientist at MIT's Computer Science College of Computing. And I founded a lab called Data to AI and also founded a company, a startup called Data which is sort of a mix of data and SIBO. So placebo, data and placebo. And I'll go a little bit into that as well, but today's topic is how synthetic data created using generative AI can help you competitively. And I promised myself I titled it that way, so I want to make sure that at the end I have a minute to answer that question. I don't have a slide that answers that, but hopefully throughout the talk I'll make some points that address that question. So what is synthetic data? It's AI-generated data. In today's world, it's AI-generated, but typically it's a machine-generated data, not generated by humans or not generated through any sort of observations, that resembles the real data in all its properties and essentially is indistinguishable from the real data. So that is what a very classic definition of synthetic data. Now, you have seen synthetic language, so you can go to ChatGPT and talk to it, and it is machine-generated language. It is something that you're not able to distinguish whether a human at the other end wrote it or a computer is writing it. In this case, I can because, I mean, we are definitely better than Stanford, and Stanford has good weather, so I could detect it that it was machine written and not, and probably AI from Stanford wrote this. You also are aware of synthetic images. So you have, these are all the faces that actually don't exist. These people don't exist. These are created using neural networks. These are facial images created using neural network. You can look at that source. I mean, we will have these slides available. You can look at that source and see how these were generated. And a lot of this sort of ability to create real images came from an area called generative adversarial networks around 2014. It pushed this field far ahead of anything else, and that's what we're seeing right now. It's called generative AI, and there was a steady stream of newer and newer algorithms that came out every year. But this was one of the first ones where you have two neural networks competing with each other. One generates the face images using random noise, actually, and the other one takes the real faces and tries to discriminate and detect whether a generated face is real or synthetic. And in competing with each other, they actually try to improve each other. And as a result, the generator becomes so good that you can give random noise and it will create a face, a realistic looking face. So that's the whole concept of generative adversarial networks. But the question that my group always focuses on is, a lot of data that is collected is tabular. It's neither images nor language. It's actually tabular data. And these are the data sets that are collected when we interact with our physical world. So when you use your credit card, when you go online, and when you go to Amazon, you log in and you try to purchase something, all kinds of interactions that you have. You go to train station, you swipe your card. You're just interacting with physical world. That data is captured and collected and put behind firewall in databases. So what about that data? Can we synthetically create realistic looking data that is at that type, which is about interactions for our physical data? So my group in 2019 did a similar GAN approach for tabular. It became the most popular GAN as of today. It's called CT GAN, where we try to use the same concept essentially. We try to supply real tables, real tabular data, and we used a generator using random noise, try to create not generated faces, actually tables, generated tables, and try to check if we can generate realistic looking data. And we succeeded. This was published in Europe's 2019. And since then, there have been several thousands of use cases for this particular model that has been available to people to use. And I'll go into that a little bit. So what is synthetic tabular data? So this is how it looks like. Can you tell which one is real, which one is synthetic? Neither can I. This was this was actually generated by collaborators of ours for their data. This is an insurance data set. And I have to always ask them which one was the real, because they actually know which one is real, which one is synthetic. So they used our software to generate this data. So I ask them all the time, every time I go on stage, because I forget. I think the left is the real data and the right is the synthetic data. And this is the the real benefit. You will get very realistic looking data when you try to generate using generative model. So why do we need generative model for this type of data? So to answer that question, let me take you back a little back in history. Almost 12 years ago now, spring 2012, the first course of edX was released. It was 602X. Many of my colleagues may recognize that course. There's 153,000 students registered and 7,000 students successfully completed that course. Every time a student logged into an online platform, a log event was captured, much like this event in which somebody was using the browser to answer an assignment or looking at an assignment. And we had like 150 million log lines like this for across 150,000 students we have. So how does that relate to synthetic data? The problem was we had a lot of questions, we had a lot of data and a lot of questions, and a lot of students interested to work on the data. The only challenge was there was only one secure machine that was approved by MIT at that time. Remember, this is almost 12 years ago. So cloud was also new at that time. We didn't know what virtual private cloud meant. So there was only one machine that was approved, and the data was residing on that. So as a result, I had at one point 23 students, undergraduates and master's students, and I had to schedule them in a round-robin fashion to work on that machine. So this is in 2012. At which time all of us had laptops and we had connectivity everywhere, right? But we still were stuck in bottleneck. We had a bottleneck of data analysis. So what did we do? What we did was we first created a generative model. This was the first generative model that we built on that data specific to that problem. And from that generative model, we created click-by-click data. So we actually recreated students and their clickstream data as if it were happening on the platform. We call that, this is a thesis from one of my students. He's actually in OpenAI right now, but this was from 2015, where we called it the synthetic student. So we created, I'm just pasting here abstract. I just looked at it this morning. I actually hadn't looked at it for 10 years almost now. And in this, we present a generative model that learns from the student data at the click-by-click level. And with that data, we can now give it to different students. They can work on data analysis tasks and give us the software to apply to the real data. So that's how we mitigated the bottleneck that we had. Then the question obviously became how generalizable this is. So we had several industrial partners that had data, and every time we work on a project with them, all our conversations come to a grinding halt when it comes to data access. So they have proprietary data in their databases. How do we get access to that? So it turned out that this thing that we did with the student data, we can actually generalize it for any relational databases. So that became a platform, an open source platform called Synthetic Data Vault. It's a generative AI platform for tabular data. What it does is you give it multiple tables of real data, you program it in such a way, and you get a generative model. Generative model is just a simple one file that you get. It's a very simple file. You use that file, and then you use the software to sample and recreate multiple tables data set. So your original data could be terabytes of data, but your model will still be a couple of gigabytes. And from that gigabytes, you can recreate as much data as you want in the same shape and structure and format. If it's multiple tables, it will capture multiple tables. So how does it do it? It automatically learns the relationships, connects the data across multiple tables, takes out the data, and learns the correlations between every two columns, every pairs of columns. Then from that, it also learns hierarchical relationships with between multiple tables. So for example, if a customer on an average in this database has 5 transactions on Friday, it will emulate that. It will learn that property from the real data, and it will create that property in the synthetic data as well. And then it just creates one model file. So it just makes one simple model file of a couple of gigabytes. So in a way, it's a compression algorithm as well. Generative models sometimes could be viewed as a compression algorithm as well. And for this particular data modality, especially. And so that's what we did. And then we did this experiment in 2016, saying that we claimed that this could actually replace real data. So how valid is that claim? So what we did at that time is that we took 5 different data science competitions that were going on, and we took their data. We built synthetic data from it, and we hired data scientists, freelance data scientists, and we gave them different versions of the synthetic data and asked them to do data science work as if they were doing it on real data. Right, so we would just give them synthetic versions. They don't know that they're getting synthetic versions. And they work on that data. They write software on that data, classical data science tasks where they do feature engineering, data transformations. This is classical data science tasks. So they will do this. They will supply us the software. We take that software, apply to the real data, submit their results onto the competition website and see how they fare. To validate whether real versus synthetic, if there's any difference, we had one group that got real data, and the other group got different versions of synthetic data, including by adding some noise to it. Right? So the whole point is, can people do work on synthetic data, and is that work good enough for us to be able to use it? So the result of this experiment at that time was that with 5 data sets that we used for 5 competitions and 3 versions, we had roughly 15 comparisons. In 7 comparisons, there's no statistical difference between the groups who worked on synthetic data versus the group that worked on real data. In 8 of those comparisons, there was significant difference, but 4 did better work on synthetic data. We still don't know why that was, but they did much better work. The result from their work on synthetic data was much better than the real data. So this showed us that there is a lot of promise to this ability to build generative models and sample data, and it just will unblock the data science bottleneck, where if you are struggling with data access and you don't have enough data access, you can use synthetic data instead. So we then open sourced the SDV platform. You can create single table, multi-table, time series, anything but language and images. So I purposefully stayed away from language and images because I thought there would be huge competition, and rightfully so, there's a huge competition right now. But in this space, we pretty much are the biggest sort of generative modeling technology in this space. As a result, we had to create our own metrics, our own benchmarking system, our own different modeling techniques. So we created a whole ecosystem of how you model this business data and sample from it. So just to give you the progression, summary of the progression that we had, we started with the synthetic student, which was very customized to one particular synthetic data, type of data. And then we went from single table to 3 to 5 tables to 30 to 50 tables and time series. And now we can do up to 100 plus tables. And we can model GPS data, phone numbers, addresses. We can create realistic looking addresses, phone numbers, and other kinds of data as well. So I will just go through a couple of summaries about what happened after the open source. We found, as of date, we count 2 million plus downloads, almost 50 plus Global 2000 companies, and at this point, maybe 70 to 100 are using SDV actively. So what do they use for? So interestingly enough, beyond that original data access bottleneck, people have found many different uses for synthetic data, which actually is much more fascinating. One is to train robust ML models, de-bias your real data. So if your real data has bias, try to engineer data that will de-bias the real data, simulate novel scenarios, and ultimately sharing the data with external parties or developers who can't access, whether it's machine learning engineers or developers, it still happens to be the most prominent use case. So I'll give you quick examples of what we mean by robust ML models. So in most machine learning, most problems where you're trying to predict something of value, you will find the one thing that you're predicting that's of value, you have very low occurrences of that. So in this case, in fraud detection, you have 0.4% fraud transactions, where you have millions of non-fraudulent transactions. So the problem with machine learning models is they quickly hone into the non-fraudulent transactions and they miss out on fraud. So a UCLA team built synthetic data, created synthetic data, fraudulent data, and added to the real data to train better machine learning models and improve the accuracy by 50%. Similarly, in medical space, you have, in this case, Imperial College and Accenture created synthetic cystic fibrosis data, where only 80%, in their original data, only 80% of the people had survived, 80% were survived and only 20% had bad outcomes. That's a good news, but still for learning whether to predict bad outcomes, they needed more data. So they created synthetic data, added to the training, and created more robust machine learning models. Similarly, MasterCard used to remove model bias. So they had a data where they're trying to just test, predict whether whether somebody's going to make more than 50K in salary or not. And they had less, 30%, in their original data, they had 30% male and 11% female that made more than 50K. They tried to de-bias that data by adding synthetic data. Sorry, I think I probably clicked. And another use case that is actually on our website, you can try this out, where what we do is we take all the data, in this case from the transportation department, the airlines data and the weather data, combine it and build a generative model using SDV. With that SDV, with that model, you can simulate a scenario. You can say, what happens if there's a storm in Midwest on April 5th? Show me how the flights actually get, all the delays percolate across the United States. You can ask things like, what happens if there's a snowstorm during Thanksgiving in Dallas, Fort Worth? And what happen, how the flight delays will happen. So then as a result, you'll get the entire resulting flight schedule across the United States. So this is a simulation. This is not reality. You're trying to simulate using the generative model different scenarios as to what's going to happen. Last but not the least, this is where we started, which is data sharing. So one of the prominent use cases is software developers. So more and more software applications are data-driven. That means they have a lot of data-driven logic. And to test that logic, engineers and developers need data. And they rarely get access to production-level data, especially in the volume, large volumes of it. So in that situation, synthetic data is very handy. You can use synthetic data to test your applications. To just give you an idea, it saves 5 full-time effort days. This is estimated by a bank, a top 20 bank in the world, per release, per application. There are thousands of applications in a typical bank. So you can imagine if there's average 12 releases, that's around 12,000 times 5, 50,000, 60,000 full-time effort days that this saves. Because otherwise they would be actually either waiting for the data or creating manually, rules to create data. So this is our team. I think some of the names are missing, but this is our team. A lot of this team had worked on this project from 2012 till date, actually. Alisa goes way back in 2013. They were at MIT. They went to different companies, and I brought them back and founded Datacebo with them. So now we sort of take SDV to market as a product. I'll end with this slide, which is, we started by saying that, you can use synthetic data for competing in data science competitions. You can give synthetic data to data scientists. And in 2021, I think most sort of popular data science competition websites like Kaggle and even Wells Fargo now start to use SDV. They've started to use SDV to create generative models for enterprise data, create synthetic data, and release it for competitions. So what we thought originally was one thought experiment, now it scales to several enterprises using the same strategy that we used. My time is up. Thank you.